Are you curious about communication? Let's break it down. Computer communication is basically how computers and digital devices exchange data over networks, whether wired, like copper or optical fiber, or wireless. This process relies on communication protocols, which are like rule books that define how data is formatted, sent, routed, received, and interpreted. Protocols make sure devices can talk to each other correctly and reliably, handling acknowledgments, errors, and retransmissions. By following these standardized rules, different systems can communicate efficiently, scale easily, and work together seamlessly. Computer communication works by taking data, breaking it into smaller pieces called packets, and adding extra information such as addresses and error checks. All of this follows agreed-upon communication rules or protocols. These packets are then sent over a communication medium, whether it's wired, optical fiber, or wireless. On the receiving side, the system follows the same protocol rules to interpret the data, check if everything arrived correctly, and request retransmission if something went wrong. The OSI model helps explain how this happens in a structured way. As data moves from the application down to the physical network, each layer adds its own information. When the data reaches the receiver, the process is reversed. Many companies are shaping computer communication, each targeting different needs and scales. Long-established players like Cisco Systems and Broadcom build core networking equipment such as switches and routers that power today's networks. At the data center level, companies like NVIDIA focus on high-speed technologies such as InfiniBand, enabling efficient data movement for AI and large-scale computing. As performance demands increase, ultra-low latency communication becomes essential. Companies like Dolphin Interconnect and Giga.io address this with PCIe-based communication for tightly coupled systems, while coherent solutions such as NuMassScale enable shared memory architectures with a unified global address space. Looking ahead, rising bandwidth and energy constraints are driving interest in optical communication, with innovative companies like Lightmatter pushing new limits. Beyond hardware, communication software plays a key role. Frameworks such as OpenMPI sit on top of networking hardware and provide standardized abstractions for parallel and distributed applications, enabling performance and scalability across clusters and data centers. If you'd like to explore the companies, startups, and investment opportunities shaping this space, check out our Patreon for deeper insights.